physical science time. So let's talk about today. We're going to talk about acceleration and maybe force. I might put that in parentheses because if there's time, we will talk about it. I don't anticipate the acceleration bit taking very long. It might, but if it doesn't, we're going to talk about forces too, and force. Have you heard the word acceleration before? I know you have. Raise your hand if you've heard the word acceleration before. I want to hear, Colton, what's your current appreciation of the word acceleration?
Acceleration can go both ways. You can accelerate forward and you can accelerate when you stop because it is a movement.
Excellent, thank you. So we're actually, the only problem I have with that is that it's not necessarily itself a movement, but it is the change in motion. Let's write that. Change in specifically velocity. That's all it is. I would say this is a perfect definition, but we're going to break it down a little bit so that it's more understandable. But it's a change in velocity. I might even go as far as to say, I'm going to make this fancy, any change in velocity. Any change in velocity is called acceleration. And then I'm going to make it even fancier. I'm going to say, also, only change in velocity is acceleration. And we're going to talk about what that means in a second. The knee-jerk test for is it accelerating is it changing velocity. That's what I mean by only change in velocity. If something is accelerating only if its velocity is changing. You know what changes? The room that you're in used to be pointed that way. I mean the room didn't, but the tables all used to be pointed that way. It has changed. What does change mean? When something is different from how it used to be. I don't know. Get it drilled into your noggin that change means when something is different from how it used to be. Remind us, Jaden, what is velocity?
Velocity includes the speed of an object in a direction.
Speed in a specific direction. Whoops, let's spell it direction like a normal person. Direction. Speed in a specific direction. Nice. And here's what, every single time I talk about this, I do this. There are 3 ways an object can accelerate. And then after that we're going to say there are 2 ways. No, I don't want to say it that word. I want to say there are 2 circumstances in which an object ain't accelerating. Ooh, let's do it in Roman numerals. We're all rich. We all have grandmas who have clocks. Okay. I'm going to get us a different marker from this one.
Oh yeah, question.
What? Yes, Justice.
Would 8 be VIII or IIX?
8 is VIII. They only. This is not the point of the question. But the Roman numerals generally only do the one fewer than thing if it's just 1. Almost always. Do you see what I mean?
Yeah.
Like 9 is IX, but 8 is not IIX. They only go 1 before it.
Okay, that does make a lot of sense, but yeah.
Usually. Anyway, okay. So if we know, which you should because I told you, that acceleration is a change in velocity, and the velocity is speed in a specific direction, what are the 3 ways an object can accelerate? Just as Colton said, because he pointed out, and I'm really glad you said this, Colton, because a lot of people, in our daily usage, and I know this is not what we're talking about, and you should know that too, but when we, in our daily usage, talk about acceleration, what do we mean specifically usually?
Like gaining speed.
Yeah, like gaining speed, going faster. If I'm the state patrol and I'm saying, well, the perpetrator's accelerating down Highway 20, I mean they're going faster, usually. And that is one of them. What is one way an object can accelerate?
Backwards.
Well, hold up. What is one way an object can accelerate related to what I was just talking
Or
about?
lower.
No. What is one way related to what I was just talking about that an object can accelerate?
Moving faster.
Yeah, moving faster. When a person in their daily usage talks about it, they probably mean speeding up. I guess it's a button. The button in your car that makes it go faster is the accelerator.
The button?
The button. Yeah, I'm going to call it a button. I like it. It kind of is. I guess we should probably technically call it the throttle. But then we do colloquially refer to that as the accelerator, which we mean speeding up. But that's only one of the three ways the object can accelerate. So look at this. How else could it change? Yeah.
Mr. Cunham, you were right with the buttons real quick, because in a lot of cars they have certain modes, they have eco mode, sports mode, and all that, and a button can change the speed.
And it's usually, actually I think nowadays the accelerator is fly-by-wire, which means it's actually an electronic thing. In the olden days, the throttle would open up the actual fuel line to make more fuel go in the engine, and the carburetor would then take in more air, and the engine would just go faster. But nowadays it's usually fly-by-wire, it's all electronic, and so you put it down a little bit and it's technically an electrical signal. Anyway, what's another way that an object can accelerate? Yeah. Slowing down. Yeah, that's the one we don't think about in our daily usage very much, but it is true. The velocity, the speed, can change in either direction. It can go faster or slower, and both of those are a change in velocity, and therefore both of those are an acceleration. So we all have these layers. On the bottom layer we have speed and direction, and those make up velocity. And then if either of those is changing, we've got acceleration. And then here's a little spoiler alert. What causes these accelerations?
Speed.
No, what causes the acceleration? What must happen?
Force.
Force, specifically unbalanced force. So we've got these layers here that we look at this, and if this is changing, then this is changing. And if this is changing, then it is accelerating. And if it is accelerating, there must be an unbalanced force. So we've got these layers of stuff we talked about. Anyway, what is the other way an object can accelerate? Even if it's neither speeding up nor slowing down. Nope, that would be slowing down. If it's stopping, then it's slowing down. But even if it's not changing its speed, has a constant speed, how could it still be changing velocity? Yes?
Going around like a car.
Yeah, changing direction. Remember, velocity is speed and direction. So both of these are talking about changes in speed, and this one is change in direction. Because guess what? Velocity is speed and direction. These two things together are velocity. He's drawn this triangle. Why is he drawing triangles? This is not pentagram time. What are the triangles about? Does anyone know? I think we talked about this last year.
Symbol for geometry.
Is symbol for?
A plane. Delta. I don't know.
Yeah, it is delta. Good, Justice. I still knew that from video games, but this is the capital letter delta, the capital Greek letter delta, and in physics it means change in.
It's also
dot.
what you put before 3 points on a plane.
Oh, really?
Exactly.
Interesting.
Geometry.
Oh, yeah. The delta in physics, this symbol means change in a quantity, and so whatever quantity follows it. So this is kind of a little side note. Here's the side note box. Side knot. Now it's side note. If I have delta lowercase t, what does that probably mean?
Delta
Delta
time.
over time.
Yeah, so change
Delta
in.
time.
Remember, delta means change in, so change in time.
Change in time.
What if I have delta capital T? Change in. If we know it's still going to change in, what would capital T be? Though?
Capital time.
Very good.
Capital.
Temperature.
Oh.
But the delta any variable is change in that variable.
Is this?
What would delta lowercase h be?
Is it? Sorry, off topic.
That's right.
Is it MTSS day?
No, it's ACT. Anyway, delta lowercase h would be change in height. When might there be a change in height?
When you
Like,
grow taller.
Puberty. That's right. Very good. Now we're going to talk about puberty. No, I'm just kidding.
Brett's question.
What is easy?
What?
You said easy E or something like that?
ACT. Anyway, two circumstances in which an object is not accelerating. So if acceleration is change in velocity, and these are the ways it is accelerating, it is changing velocity. What are the two ways? What are the two situations it's in where it's not accelerating? Stopped. Yeah, if it's completely stopped, it is not accelerating. But there's another one that's more, I think, more interesting, and people don't. Yeah, what is it?
When you're staying at a constant speed.
Yeah, constant speed, but not just that. Constant speed and
Constant velocity.
well, really, that's more accurate. Constant velocity. We're going to say constant speed and straight line or constant direction.
Same direction.
Yeah. Okay, now here I told you. Here's how you can tell. This little, I don't know, pyramid of physics is how you can tell if something has a force applied because it has an acceleration, because it's changing velocity, because one of these two is changing. But how can you because you're an animal and you have these instincts, you can feel when you're accelerating.
I can feel nature.
So think about this. If you speed up, imagine you're in a car, because we have a lot of experience with cars. Can you feel, even if you have your eyes closed, Can you feel when your mommy slams on the brakes?
Yes.
Yeah, because she's slowing down. Your acceleration is changing. Can you feel the difference if she's going to floor it to go through the intersection before the yellow light turns to red?
Yeah.
Yeah, you can feel that. Can you feel if she changes direction?
Yes.
Yeah, but can you feel if you're stopped?
Yes.
No.
Well, like, you can feel the
change.
decrease.
Yeah, but no, stopping. But if she's stopped, you don't feel any different. What if you're moving at constant speed in a straight line?
You don't.
No, that's probably because you are. That's probably when you feel safe.
Unless
But if you're taking bumps, you're changing in direction, even for just a second. You're going up instead of straight. Yes.
So, real quick question. So, sometimes I'll be sleeping on, say, like a car ride home, and I feel a turn, and I know it's a turn in my house.
Yeah.
Is that, would that be almost like
Instinct.
instinct or muscle?
Yeah. Oh.
Yeah, because
Maybe
like-
not just instinct, but your body naturally tries to keep your head up, right? So if you start to be, your body starts to be forced this direction, you activate your core a little bit so you don't fall off. Yeah.
No, but I mean, like, how do you...
Yeah, I get it. Okay, so when we're
Don't worry too much about it. This is just a little side note. The delta just means change in a quantity. So these are two examples: change in time and change in temperature. Yes, Saracen.
okay, so like when we're going home from Rapper, like sitting in the car, and like we slow down, I wake up.
Yeah.
Like, we start
Because
slowing
it's
down, we
acceleration.
start- I know when we
It's an
turn.
acceleration. Cool.
But anyways, so what, I know you're not helping, but what I'm trying to ask is, how do you recognize that you are where you're at without looking at it?
You don't do that without looking. You still realize it because you know things. Like it's not even instincts. You're just using a different you're
Language.
cogitating in a different part of your brain. You're thinking about it, but you don't realize it. It's subconscious, maybe you could say subconscious. Still stuff you know. Same way you know how to ride a bike, I would say.
I don't know how to ride a bike.
I know how to ride.
You know how to sail a ship, though, Mr. Fitzwilliam, and you're good at it. Okay, so how do we calculate this then? So we have this idea of acceleration here. What are we going to have to do? If we know that acceleration is change in velocity, what definitely is acceleration going to depend on? First of all, acceleration, like velocity, has an arrow over. It's lowercase a with an arrow, and that means it's a vector quantity. It depends on a direction. Acceleration depends on a direction. Well, what do we know it's definitely going to depend on?
Direction.
Yes, because it's depending on what quantity. Both of those together make velocity. So we know, so delta V, change in velocity over time. Sometimes we even put change in time. It doesn't really matter. Yes,
What if the arrow is the other way?
it doesn't matter. We always indicate it with this arrow going that direction over it. That just means it's a vector quantity, even if it's going the other way. Thank you, Peyton.
And that delta V over delta T equals velocity?
No.
No.
Acceleration. And then anytime there's a delta quantity in anything, we can rewrite it this way. We write it as velocity sub f, which means final velocity, minus velocity sub naught. We pronounce that 0 naught, which means initial velocity, over time final minus time initial. Anytime there's a delta, we can change it to this final minus initial. What does final mean? I'm measuring these things, so what would the final velocity mean?
What your final?
How I measure it at the end of the time I measure it. What would initial mean? How I measure it at the beginning of when I measure it, right? It's just the last measurement you take minus the first measurement you take. So let's do an example of these real quick. Well, do you have a horse? What's your horse's name? Stormy? That's a good name for a horse. Stormy, and Colin, no one cares. Stormy is coming to a halt near a cliff. You know how horses do. Like, Colin's trying to ride the horse off the cliff because he's had a bad day at school or whatever. But the horse is like, I'm not having it. And so puts on the brakes and he's coming to a halt. She was traveling
That she found.
at 30 meters per second. It's a fast horse. That's a really fast horse. Let's reduce that a little bit. 10 meters per second.
That's a really slow horse.
That is the really slow horse.
This maneuver
Maneuver.
takes her 1.2 seconds. What is her acceleration? So using our context clues, what are we trying to solve for here? For what are we trying to solve?
Acceleration.
Acceleration. What should I do first?
Write the wrong equation.
Which is?
A, that little liney thing equals,
Yeah, A arrow, sometimes we call it.
I don't know.
A arrow equals?
That delta thing.
Okay. Thanks, sorry.
Okay,
I
and
don't know
then
why I wrote this
velocity
locally.
without
But velocity over.
over delta time.
Yeah, but we're just going to call it t here. Because we have a, in this case, we have a time interval. This is for if you have like, wouldn't really work with clock time, but if you have like, your final time is 30 seconds, your initial time is 22 seconds, you're just measuring it in between of those. But since we have a time interval, since we have an elapsed time here, we're going to use just t. Yes, Peyton, what's your question?
Oh, I didn't realize I was handing.
Okay. So, what should we do next? Do we need to manipulate this at all? No, because we're solving for acceleration. So what should we do next?
Substitute.
Substitute. So A equals, and I'm going to rewrite the delta V like I can as V sub f minus V sub naught, because I have two different velocities, don't I? Wait, I have this one, 10 meters per second. What's my other velocity?
Whatever that.
0, because it's a halt, it's stopped. Over time. Okay? So, final velocity, be careful. What's the final velocity? Think about it.
The final velocity.
Yeah, what's the final velocity?
0.
0. She's coming to a halt, so final velocity is 0. What was the initial velocity?
1.25.
No?
Isn't that 10?
Oh,
10 meters per second.
Meters per second.
And
Over,
1.25 was the time it took me to
the
stop.
time is 1.25 seconds. Sorry, 1.2 seconds. I don't know where the 5 came from. 1.2 seconds. How exciting. Look what's going to happen on the top. What does a parenthesis mean in...
Multiply.
No. What does the parentheses mean in... Parentheses mean what in math? Do that first. So what's 0 minus 10? Negative 10 meters per second divided by 1.2 seconds. It's negative 10 divided by 1.2.
I got you. Sorry. 110. You said 110.
10 divided by 1.25.
No, not 1.25, Paul. I don't know where that's coming from. 1.2. This is 1.2 seconds.
That's, I forgot. That's it. That's never mind. My bad.
Times or divided by 1.2.
Someone else needs to do this too, because I'm not... We can't just trust one person.
Negative 91.
Maybe. Someone else do it too, please.
Calculator.
You have one.
What does it
I have a
say
calculator.
all on there, like at the end? I couldn't.
You don't have to write this.
I said
This
one-
is just
you said
my writing
110,
down
right?
the question.
Or 10.
Negative 10.
Yeah. I lied to you then. So I actually put one.
Negative 8
Yeah, I actually put one.
Negative 8? Just negative 8?
meters per second.
Negative 8.3. Wait, but look. Is it meters per second?
No, it's
No,
meters.
it's
No, it's not meters. It's...
it's seconds.
Miles.
Watch this. It's meters per second which we sometimes write as meters per second squared.
Square.
Oh.
What?
What that means is every second that goes by, her velocity is reducing, because it's negative, by 8.3 meters per second.
I thought we don't do negative 10 divided by 1.
Yeah, we do. Is that not right? I asked two people and I had two different
Well,
answers.
yeah, I know. I
Divided
actually
by,
did one time, actually.
But what is it?
It's 8.3.
Okay, so negative 8.3.
We gotta make sure.
What does it mean?
1,700.
Right, you have
Seven-
to dividing
No.
it.
10 divided by 1.2 is not what you said.
Yeah, it's 8.3.
10 divided by 1.2?
Yeah.
Yeah, but you get 8.3 or
So anyway, let's talk about these two things then. What do positive and negative acceleration mean? This is pretty simple. Positive acceleration and negative acceleration. What do they mean? If our answer comes out negative, what does that mean?
It's
Slowing down. And what does it mean if it's positive? Speeding up. Think about it this way. The meters per second squared means that every second that goes by, the velocity is changing by this much. And if it's changing by a positive amount, it's adding that velocity every second. So that means it's gaining speed. If it's a negative amount, it's subtracting that velocity every second. So it's losing speed. It's slowing down. We might even say it's stopping. Peyton. You really need to right this second?
I've been waiting since 30.
Well, you've asked like 4 questions since then, so you could have said, can I go to the bathroom then, but that's fine.
Well, I figured I could wait, but
But then things changed. You better go. Okay. We won't have time to talk about forces today, but basically, all of this you should know is caused by force. In this case, what force is causing Stormy to come to a halt?
Acceleration.
Well, acceleration is not a force. A force is causing the acceleration, but what force is causing this?
Cold
The
hit
fact
inside.
that she doesn't
No,
want
no.
to die.
Okay, that's not a force. We can think of it as an emotional force, but it's not a force itself. What force is causing this? What force allows the brakes to work?
Legs.
The legs, specifically the hooves interacting with the ground, which we call what?
Friction.
Friction. It's the friction. The friction between the hooves and the sandy cliff face are preventing her from going overboard. And Poland just sits in the saddle and cries. Bye!